Hello student, I am Dr.A.K. Sinha, Professor of Chemistry. Today I am going to discuss chemical properties of alkanes. Last class I have discussed physical properties. Now I am going to discuss chemical properties of alkane. First reaction I will tell about the substitution reaction. Actually, alkanes are generally inert. Alkanes are generally inert towards acid, bases, oxidizing and reducing agents. However, they undergo substitution. Some reactions are there, like substitution reaction, combustion reaction, and some oxidation reaction is also there, partial oxidation reaction, or you can tell controlled oxidation, isomerization, pyrolysis, reaction with steam. Then these reaction alkanes will go. Okay. Then I am telling now substitution reaction. What is the meaning of substitution reaction? Already I told you. Again I am telling you, one or more hydrogen atoms of alkanes can be replaced by halogens, nitro groups, and sulfonic acid groups. It can be replaced. One or more hydrogen atoms of alkanes can be replaced by halogen groups, nitro groups, and sulfonic acid groups. Halogenation takes place either at higher temperature. Higher temperature means between 523 to 773 Kelvin, or in the presence of sunlight, in the presence of diffuse sunlight or ultraviolet light, UV light. Diffuse sunlight means morning light. Morning light is called diffused light. Or sometimes in ultraviolet light, UV light, highly energetic. Lower alkanes do not undergo nitration. Here you remember. Lower alkanes means carbon number is less. That type of alkanes do not undergo nitration and sulfonation reaction. Okay. Means lower alkanes means carbon number maybe 1, 2, 3, 4 like that. Lower, it will not go for sulfonation reaction or nitration reaction. These reactions in which hydrogen atoms of alkanes are substituted are known as substitution reaction. Okay. Reaction in which hydrogen atoms of alkanes are substituted are known as substitution reaction. Means in the place of H, other group will go. H will go, other group will come. That is called substitution reaction. Now I am giving one example of chlorination of methane. Chlorination of methane, CH4 plus Cl2. This reaction takes place in presence of UV light, ultraviolet light, also called H nu. Planck constant, and nu means frequency, H nu. Then here what will happen? This reaction is very interesting and quickly can be understood. CH4 plus Cl2 in presence of sunlight, or H nu. H nu is actually telling about the energy. Planck constant is H, nu is the frequency. Then here reaction, what will happen? CH4, 4 hydrogen is there, and Cl2. If both will react, then what will happen? Every time actually this reaction will go in a step wise. Then CH4, 4H is there and Cl2 is there. Then Cl2, first it will break into Cl and Cl atom. Radical form. Cl and Cl bond will break, then both will take one electron in presence of sunlight. Then Cl have one electron, other Cl also have one electron. Both Cl has one electron. That is called a radical, chlorine atom radical. Chlorine radical. Then this radical, what will happen? It will attack with methane. CH4, 4 hydrogen is there. Then one bond will break. CH bond will break. Then when this bond will break, this is also happening in presence of sunlight. Generally in sunlight, that radical will be formed. Radical means bond will break and both will take shared electron. What they have shared, they will take back. Then C will take one electron, hydrogen will take one electron. Then now this C has one electron and hydrogen has one electron. Then now 2 Cl is there. Then 1 Cl will come to the carbon and they will make one bond, C-Cl bond. And H will make bond with other Cl, HCl. Hence it will give two product. Methyl chloride means CH3Cl plus HCl. That is the one hydrogen replaced. Now after that, now 3 more H is there, CH3. Then again this Cl2 will come, fresh Cl2. Then again same thing will happen. That CH bond, second CH bond will break and one chlorine radical will join with carbon and one hydrogen will join with other chlorine radical. Hence again, now this time it will form CH2Cl2 because 2H gone and 2Cl came. Then CH2Cl and again 1HCl. Correct? Now two more H is there, CH2Cl2. Then now in this situation again third, same thing happened with third. That now in third step, what will happen? Again Cl2 will react. Cl will give two radical, it will produce Cl having one electron. And this CH2, that one again H will go, third H will go. CH bond will break. Again same thing will happen. C will make bond Cl and now it become CHCl3 plus HCl. Plus HCl. Now one hydrogen is remaining. CHCl3. This is also called chloroform. Okay. CHCl3 is also called chloroform. Then now this hydrogen, fourth hydrogen also it will bond will break and plus Cl2 is there. Cl one radical, other radical also Cl is there, two radical. One Cl will come with carbon again and again they will make bond. Then now it will form CCl4. All 4 hydrogen replaced with 4 chlorine radical, 4 chlorine atom. Then now and that fourth H again it will react with the other Cl. It will form HCl. Means in this reaction total 4 HCl will form finally. In each step 1 HCl. And every time 1 H will go, other Cl will come. 4 H was gone, 4 Cl came. And finally it form, fourth step it will form CCl4, carbon tetrachloride. It is a liquid. Okay. Then every time 1 HCl form and every time one carbon H hydrogen bond broken and 1 Cl came every time. Then first step you can say it will form CH3Cl, one hydrogen gone, one Cl came. That is called chloromethane or methyl chloride plus HCl. Second step, second hydrogen will go. Then it will form CH2Cl2. That is called dichloromethane and HCl will form. Third step, third hydrogen will go. Then it will form CHCl3. That is called trichloromethane. Second was called dichloromethane. Third was trichloromethane. And first was called chloromethane, monochloromethane. Mono, di, tri. All are methane only. Monochloromethane or simply chloromethane. Second, dichloromethane. Third, trichloromethane plus HCl. And fourth, again same things. CCl4, tetrachloromethane or carbon tetrachloride plus HCl. Trichloromethane is also called chloroform. Then this I have told, this is called halogenation. Halogenation, and all reaction takes place in presence of light, UV light or H nu. Arrow sign you have to write and upside H nu you can write. Then this I have told you about these things, halogenation of methane. Here these things, this just like methane, ethane also can react. Ethane, CH3CH2 or say ethane is CH3CH3 ethane C2H6. Then same reaction, same step here also can take place. CH3 is there. Then now first CH3 leave it, second CH3 in that 3 hydrogen is there. Then all 3 hydrogen will can replaced and it can form different compounds, but generally one hydrogen will replace fast. Okay, other is also possible. Then it will form 3 CH3. The second CH3 I am talking about, one H will go and in its place one Cl will come. Then it will form chloroethane. It will form chloroethane plus HCl. This reaction also takes place in presence of H nu, means sunlight. It is found that rate of reaction of alkanes with halogen, now fluorine, chlorine, bromine, iodine, all are called halogens. Then which will react fast out of this fluorine, chlorine, bromine, iodine? Then it is found that the rate of reaction of alkanes with halogen is, with fluorine it will react very fast. After that chlorine, after that bromine, last is iodine. Okay, this question is asked that alkane will react, means with which it will react fast, rate of reaction will be with whom it will be fast or fastest. Then fluorine is the top, after that chlorine, third position is bromine, last position is iodine. Rate of replacement of hydrogen of alkane is in term of degree you can tell 3 degree, fluorine is 3 degree, second and after that second degree is chlorine, third degree is iodine. Okay, rate of replacement of hydrogens of alkane, CH3 is there, then 3H is there, then first H will react, that is called 3 degree fastest. After that second hydrogen will go, then third hydrogen, then 3 degree is greater than 2 degree, 2 degree is greater than first degree. This is the you can say preference. Rate of replacement of hydrogen of alkanes is, I told you, 3 degree is greater than 2 degree, 2 degree is greater than 3 degree, means CH3, when it is in the form of CH3, then 1H will go fast, that is the third degree. After that, second hydrogen will go, and then third hydrogen. Fluorination is too violent. Fluorine will react very violently. Violent reaction will take place very fast. Fluorination is too violent to be controlled. It is very difficult to control this reaction. Iodination is very slow. Fluorination means reaction with fluorine is violent, and it is very difficult to control. Violent to be controlled. Iodination, reaction with iodine is very slow and a reversible reaction. Means it will ethyl iodide it will form. Then from the ethyl iodide, again ethane you can get. Reversible reaction. Iodination is very slow and a reversible reaction. It can be carried out in the presence of iodizing agents like HiO3 or HNO3, oxidizing agent. This reaction takes place in presence of oxidizing agent, as for example HiO3 and HNO3. Okay. Then here suppose CH4 plus I2. Now reaction with iodine, CH4 plus I2. Then product will form CH3I plus HI. Same way like chlorine. CH4 plus I2, it will form, one H will go, it will form HI, and in the place of H, iodine will come, one iodine. Then methyl iodide, CH3I plus HI. And this HI formed, now this, actually I told you it is a reversible reaction. If you don't want to be reversible, this reaction, you want to stop, it should not come back. You got CH3I, again you can get CH4, reversible reaction. Then if you don't want that it should go reversible, then HI form, that should be removed or used up. For that purpose, now reaction is done with oxidizing agent like HiO3 or HNO3. Then HiO3, suppose it is there, then HiO3 plus 5HI, both will react. If HiO3 you are using, then HiO3 plus 5HI, both will react. Then now it will form 3I2. HiO3, one I was there, now here is 5HI. 5I was there, one I this. Then it will form 3I2, means 6I, 3I2. And water molecules, because 5HI means 5H was there and 1 HiO3, there 1 H was there. Then total 6H and 3O is there, HiO3, O3, hence it will form 3H2O. Halogenation is supposed to proceed via free radical chain mechanism. This question is asked, but that question will be asked only in a written examination. This mechanism, what mechanism you have to understand, you should know. Halogenation is supposed to proceed via free radical chain mechanism involving 3 steps, namely first step will be initiation, second step will be propagation, and third step will be termination. 3 steps will be there. Chlorination takes, mechanism of chlorination takes place in 3 steps. Then first step is initiation. Now I am telling all 3 steps. Okay, because in multiple choice question also in indirect way they are asking. Initiation step, 3 step I told you: initiation, second step is propagation, and third step is termination. Then come to the first, initiation. Initiation means there what already I have discussed the reaction. Now stepwise I am telling you. First Cl2 you are taking. That Cl bond. Cl2 means Cl bond. In presence of sunlight it will break and it will form two free radicals. Two chlorine free radical it will form. Cl 1 electron plus Cl 1 electron. Two radical it form. That is called chlorine free radicals. Okay. Because Cl bond is bigger. If CH4 and Cl2 both are reacting, then CH bond is strong. That will not break first. Cl bond is weak. Hence that bond will break first. Then now this Cl bond breaks and it gives a two free radical. Chlorine free radical you will get Cl 1 electron and other Cl 1 electron. Now this Cl electron it will attack to the methane. Methane CH bond is there it will attack. Then this step is called propagation. Chlorine free radical attacks the methane molecule and takes the reaction in the forward direction by breaking the CH bond to generate methyl free radical with the formation of HCl. One bond will break, CH4, 4 bonds are there, CH, then it will attack to the methyl and CH bond will break. Then it will create methyl radical. It will create methyl radical and that hydrogen with 1 electron, it will go and it will react with the chlorine which has 1 electron. Then it will form HCl. Now one chlorine atom is there, remember. One chlorine free radical is there. Then now again it can react with the second CH bond of methyl. Second CH bond of methyl. Then now that hydrogen will also go. Okay. And like that way, again fresh Cl2 will come. Then that again, they will break the bond, CH bond, and they will come there. Okay. Like that we already told you. But here, this step, when chlorine will attack to the methane, that step is called propagation. Because it will create methyl. It will create methyl radical. Okay. It will create one methyl radical and again it will form HCl. Then now this radical form methyl radical, then again these radicals are, all radicals are very, very reactive. Okay. Methyl free radical are very, very reactive. The methyl radical thus obtained attacks the second molecule of chlorine. If chlorine molecules are many Cl2s are there, then now this you can say free radical of methyl group will attack to the Cl bond, fresh Cl bond. Now it is very reactive in comparison to the Cl bond. When methane was there, that time Cl was weak and CH bond was more like, but methyl group, methyl radical is now more reactive than Cl2. Hence this radical will attack to the Cl bond. Again it will break. Now you will get two more free radical, chlorine free radical you will get, Cl, because due to the methyl group. And after attacking, this methyl radical will react with the chlorine atom, free chlorine atom. Radical it will react and it will form methyl chloride. Again one more Cl is remaining. Then again this Cl free radical, again it will attack with the new methane. If or you can say second CH bond also. Or if more ethane is there, then same thing they will do. Okay, that's why it is called propagation. More and more reaction will take place. More methyl radical will form, more Cl atom will be there, and so more reaction will take place until it finishes. Cl and this reaction will continue. Correct. That's why in motorcycle petrol when it will start, when you are starting engine, sound comes. This sound, how, from where it is coming, the sound? Then here this reaction takes place. That is a hydrocarbon. Petrol is hydrocarbon. In that maybe methyl group, ethyl group, or generally it is a mixture of propane and propane. That 2 carbon, 3 carbon may be there. Then this bond breaks actually. This type of bond breaks. And when bond will break, then this radical will be formed. The radical will be formed. When radical will form, then again it will attack to the other molecules. Then again that bond will break. And again that radical, again it will attack to the other, because so many, you can say, radical can form, and hydrocarbons are there. Many you can say ethane group will be there. Ethane or propane will be there. Then every time bond will break. Then when bond will break, then it will produce heat. It will produce heat. That heat actually is important, energy. It gives energy to the bikes. You are driving. And that is actually purpose of petrol or diesel. Because when bond breaks, it releases energy. And sound comes due to the, because long chains will be there, then that will break. And then when it will break, then sound comes. And it will form actually this radical, methyl radical, ethyl radical. That's why actually here you are in the petrol lead, you are a tetraethyl lead you are using, TEL, tel, what you are telling, tel, that is a tetraethyl lead. That reacts with the petrol, and this type of radical forms. Tetraethyl lead will be there. Many reaction takes place there, but bond sound comes due to the cracking. Cracking means long chain, it will break, and then sound comes. And that time radical will form. Then this will continue. That's why in petrol, tail must be there. TEL, tetraethyl lead. Only then bike will run, means petrol will burn. And due to this cracking, bond breaking, sound comes. And lead, tetraethyl lead is there. Lead, then this is the heavy. Lead is the heavy. Hence it will become just like a stone, a small stone, and like a dust particle also you can tell, but it is a stone, like the sand. That's why in old bikes or old trucks, more sounds comes, and sound will be not like the new bike. In any bike, either motorcycle or tractor or truck, some special type of noise, type of sound comes due to this lead. Lead will be there. Nobody is removing that lead. Lead will be only in the engines, and it harms the you can say parts of the engine also. Inside the wall, it will strike always. This lead, it will strike always on the wall of the engine, and that's why more noisy sound will come. Okay, this I have told you some, but in advance details. Then I told you propagation step, that it forms a methyl radical plus HCl. One H will react with the Cl radical, HCl, and it will form a methyl radical plus HCl. And then this methyl radical, again it can break to the new Cl2. Cl bond will break, and again it will form Cl radical, chlorine radical, and methyl will form methyl radical. Methyl will form methyl chloride. It will react with the chlorine atom. Okay, and it will produce, because Cl2 was there, one Cl methyl used, one Cl is remaining, chlorine free radical. The chlorine and methyl free radicals generated repeat steps first and second. Two steps I told you, that CH3 means methyl CH4 plus Cl radical. This is the first step. It forms methyl free radical plus HCl. And second step, this methyl radical react with the fresh Cl2 and it forms CH3Cl and one chlorine free radical. Then these two steps will repeat. These two steps will repeat. Correct? That's why it is called propagation. The chlorine and methyl free radicals generated repeat steps first and second respectively, and thereby set up a chain of reaction. This is called propagation. The propagation steps, these first and second steps, are those which directly give main products, principal products. But many other propagation steps are possible. Many things will be, many products you will get. Then what will happen? Now I am going to discuss that is this things termination step. But before termination, I told propagation step is there. Then many products are possible. Okay, methyl chloride it will form, dimethyl chloride also, dichloromethane also it will form, trichloromethane also it can form, tetrachloromethane also it can form. All things I have discussed. Okay, but up to dichloro generally it will form, tri also it can form, other also it can form. This depends upon the situation. Now termination step I am telling you, because you have to stop the reaction. You stop the reaction, chain reaction, it is continuing, it is breaking and reaction is going on. How will you control the reaction? Then in bike, if you want to stop this reaction, if you want to stop this reaction, then what you are doing first? That first of all, you will the inside construction will be like that, some tell tetraethyl lead that you will stop. Petrol also you are trying to stop. Correct? Inside construction will be like that, that all this will be there. But there, what will be the main reaction? Is a common reaction. Yes, termination reaction. Okay, that see, two possibilities are there. Radical can join to itself, because during the reaction propagation many radicals will be there, many products are there. Then any two radicals can join. Suppose two CH3 radicals are there, then they themselves can join and it will form C2H6. Then now further reaction will stop. Or C2H5 radical is there, again C2H5 radical is there. Then both will make a bond. Now reaction will stop. That is called termination. Correct? Cl will be there. Cl radical. Then again they can form Cl2. Then reaction can stop. Okay. Then main things I am telling you, that termination, the reaction stops after some time due to consumption of reactants, and or due to the, you can say, I will tell you reaction. Suppose reaction is there, the possible chain termination steps are possible. Possible chain termination steps are radical, chlorine free radical plus chlorine free radical, Cl one electron, again Cl one electron. they conjoin, then it will form Cl-Cl bond, means Cl2. This is the first possibility. Second possibility is CH3 plus CH3, both radical, methyl radical plus methyl radical. They conjoin, it will form CH3, CH3. Third possibility is that CH3 radical is there, methyl radical plus chlorine, free chlorine radical, CH3 radical plus Cl radical. Then it will form methyl chloride. Methyl chloride, CH3 Cl bond, it will form. Then these three possibilities I have told you. Though actually those these things, carbon third step, when CH3 Cl I am talking about, the one of the production is formed, but free radicals are consumed and the chain is terminated. Means third step, what I told you, free radical plus chlorine radical, both will react. It always it will be going on. Hence, for complete termination, all free radicals should stop. They should react. Then further reaction will be not there. Completely reaction will stop. That's why this is called termination steps. Termination, that is the third step I have told you. Now I am telling you these things. Next reaction, combustion reaction. Combustion, combustion, combustion. Okay. And simple meaning of combustion is burning, bond breaking, combustion. Alkanes on heating in the presence of air or dioxygen are completely oxidized to carbon dioxide and water with the evaluation of large amount of heat. This is very, very important reaction. Alkanes on heating in the presence of air or dioxygen are completely oxidized. Dioxygen means O2 gas. In the presence of O2 gas, it reacts completely or oxidized completely. And after that, what product you will get? You will get carbon dioxide. Generally, hydrocarbons, when it will react with oxygen in the presence of heat is required to start the reaction. Then it will form CO2 plus water, because in hydrocarbon, hydrogen will be there. Then hydrogen also will convert to the oxygen, H2O. Both will oxidize, carbon and hydrogen. Carbon will give CO2 and hydrogen will give H2O. And third things, that is it will give large quantity of heat. As for example, CH4 plus 2O2. CH4 is gas, methane gas plus 2O2. Oxygen is also gas. When it reacts, it gives CO2 plus 2H2O. And heat methane, it gives minus 890 kilojoule per mole. 890, too much. Delta H is negative. Delta H is negative means it is giving out heat. It is producing heat. And what is the value of it? It is now minus, means exothermic reaction, heat is going on. Then minus 890 kilojoule per mole. Too much heat is there. And now butane, C4H10. Butane is a gas. Isobutane is also gas. Then butane means C4H10 plus oxygen. Here more oxygen is required. Why more oxygen? Because number of carbon is more. C4. 4 carbons are there. Long chain is there somewhat. C4H10. Then it requires more oxygen. How much? Then 6.5. 6.5 per mole. 6.5 oxygen is required. For 1 mole of butane to burn completely, 6.5. Remember, also you can write 13/2. 13/2 oxygen is required. and it will give 4 carbon. C4 is there, then obviously 4 CO2 it will be there, no doubt. Then and hydrogen is a 10, C4H10. Then H10 means 5H2O, 5H2, then 10H it will be there. And 4 carbon was C4H10, then 4 CO2 it will form, that is certain. And H is 10, then 5H2O it will form. This is by common sense. And heat also it will produce. Then its reaction will be C4H10, that is the gas, plus 13/2O2, and it will give 4 CO2 plus 5 H2O. H2O is a liquid, you know. H2O liquid it will give. And what is the heat? Heat produces too much. Too much heat is produced. That is the minus 2875.84 kilojoule per mole. 2875. See how much heat is producing. 2875 kilojoule per mole. Exactly 2875.84 kilojoule per mole. And here only I want to tell you, in kitchen, what you are using gas, LPG, liquefied petroleum gas, in that cylinder, gas cylinder, that cylinder, this gas will be only there, butane mixture of butane and isobutane, and they will be not in the gaseous form, they will be in the liquid form inside, because they are filled in a very high pressure. Then that's why this gas converts to the liquid. This gas converts to the liquid due to the high pressure, and because of very high pressure, their cylinder will be, a thickness of cylinder will be very, this thickness will be more, so that it should not break, because gas under this gas, inside gas is at high pressure, it will convert to the liquid. And when it will use the gas, when it will open it, then because now in comparison to the gas pressure, inside cylinder gas pressure is very high and outside atmospheric pressure is less, and that whenever that gas, which is in liquid form actually, when it will come out, then that time liquid will convert to the gaseous form. It is inside the liquid form but a high pressure. As soon as it will come out, that liquid will convert to the atmospheric pressure. That will convert to the gas, because atmospheric pressure is less in comparison to that. Then it will come out. As soon as it will come out, it will convert to the gas, and then when you are putting fire, it is catching. Correct? Then butane and isobutane is filled in the cylinder. This question is asked, and this is also example of combustion reaction. In general, I am talking about in general, because hydrogen is of different number of carbons. 4 carbon, 5 carbon, 6 carbon, like that, 7 carbon, more also is possible. Then what will be how many carbon dioxide will form, how many H2O will form. Carbon dioxide will form, that is certain. Liquid will form, water will form, that is also certain. Heat will come out, that is also certain. But how much molecule of carbon dioxide will form, how much molecule of H2O will form, how will you come to know? Balance reaction. Then one general equation is there, okay, that you have to know, and in that will tell you, if you will put the value of n means number of carbon atoms, then you will get how many carbon CO2 will form, how many H2O will form. Then that n term we are using, where n is the number of carbon. Then here general alkane, you can write formula, you know general alkane formula, CnH2n plus 2. This is the alkane, where n is the number of carbon atom. Correct? Then Cn, n value may be 1, 2, 3, 4, 5, 6. And then what will be the H value? The H value double, then double plus 2. Already told 2n plus 2. That is the number of hydrogen. Then this Cn H2n plus 2, when it will react with oxygen, then how many oxygen is required? How many? Then its value coefficient you keep in mind, 3n plus 1 divided by 2. 3n, a small n, 3n plus 1 divided by 2. This is the coefficient of oxygen. This number of you can say oxygen mole you require. 3n plus 1 divided by 2. This is the coefficient of oxygen, like 2O2, 3O2, 4O2, like that you are writing. Here it is a 3n plus 1 divided by 2. Then its value depends upon the n. And what product it will give? How many CO2, how many moles of CO2 it will give? Then this is clear. Cn is there, then NCO2 will give NCO2, that is a certain. And how much H2O it will give? How much H2O will give? Then how many H is there? Then 2n plus 2. There this 2n plus 2 is there. You have taken Cn H2n plus 2, then 2 is common, remove it. Then differing is n plus 1 is common. N plus this 2n plus 2. Then 2 you take common. The what is remaining? N plus 1 is fixed. N plus 1 is fixed. That's why here n plus 1 H2O, how many H2O it will produce? Then n plus 1. Means H2O coefficient is n plus 1, a small n plus 1. Okay. And this heat you can't tell. That depends upon number of carbon. Okay. Hence it is not required to write. Then due to the evaluation of large amount of heat during combustion, alkanes are used as a fuels. Why alkanes means hydrocarbon, particular alkanes are used as a fuels? Because see how much energy it is giving. How much energy is giving? If you require more hydrogen, if you require more energy, then you have to select such type of fuel which can produce more heat. Already I told you only methane is giving this methane is giving 890 kilojoule per mole, and butane is giving 2875 kilojoule per mole. Butane. Then if number of carbon will be more, then it will give more and more heat. More and more heat energy it will give. That energy is used in bikes. That energy you use in two-wheeler, four-wheeler, three-wheeler. But you might have seen that petrol are used only in bikes and four-wheelers. Two-wheeler and four-wheelers, petrols are used. But petrols are not used in truck or heavy vehicles. Why? There it will not work, because truck, tractors plus heavy wheels, 6 wheels, 8 wheels, 12 wheels, that heavy vehicles are there, heavy vehicles, that will not run by petrol, or particularly for petrol. Why? Because petrol gives less energy. Then that's why they will use diesel. Diesel contains more carbon number, around 12. Then that will produce too much energy. It will provide too much energy. That energy is sufficient for, now you can say, heavy vehicles, tractor, truck and other industrial vehicles. Okay, I have told you. And again, but one more thing is there. during incomplete combustion, if there will be not complete combustion, partial combustion, then what will happen? During incomplete combustion of alkanes with insufficient amount of air is not insufficient, or oxygen is not sufficient, then you will get a carbon black. You will get a black color. Carbon black you will get. And what is the use of that carbon black? Carbon black is formed if it is a, you can say, incomplete. During the incomplete combustion or due to the incomplete combustion of alkanes, it forms you can say carbon black. Carbon black is formed, and which is used in the manufacture of ink, black ink, or printer ink, black pigment, and as a filters. In filters it is used. It will absorb actually color of the any filter water. Suppose it is has some color it has, then this color will be absorbed by this black carbon black, charcoal, what you are telling. There actually it is used. And one major, you can say this, due to less oxygen, if it is not completely burned, incomplete burning, that is very, very dangerous. It produces carbon monoxide gas, CO. CO gas it produces. That CO is the carbon monoxide, deadly poisonous gas. Hence, one should be very, very careful when heavy trucks, from the, you can say, heavy trucks, whatever fumes are coming, tractor, truck, or industrial, you can say, vehicles, whatever color is coming, that is very dark color, very dark. In that, along with carbon dioxide, carbon monoxide will be there. Full dark, one should be make distance with full dark, you can say, fume, because that is the monoxide, deadly poisonous gas. Okay, and that is the reason near the where many vehicles are standing there, particularly trucks, buses, and other heavy trucks, there, heavy vehicles, there one should not stand, because they will produce carbon monoxide along with carbon dioxide. Okay, correct? That's why near the signal, one should avoid to stand there. Near the signal, all vehicles will be there producing CO2 and CO. Okay. Then this reaction I am telling you, CH4, methane gas, plus O2, what it will form due to the incomplete combustion, it will form carbon, only carbon means a solid, carbon black, only carbon means carbon black. S you have to write in bracket, solid, carbon plus H2O, 2H2O, CH4 plus O2, C plus 2H2O, in less oxygen, very less, then it will form. Okay. Now third reactor I am telling you, controlled oxidation. Then here three product it will give. Controlled oxidation means oxygen you are not supplying full. Oxygen you are not applying full. This is a controlled oxidation. Then it will give different product. Then 4 products it will give. Okay, 4 products. When methane is burning with oxygen in presence of copper, temperature is 523 Kelvin and pressure is 100 atmospheric pressure. You have to remember these things. Methane is burning 2CH4 plus O2 in presence of copper catalyst. Temperature is 523 and pressure is 100 atm. Then it will give methyl alcohol 2CH3OH. 2CH4 plus O2, it will give 2CH, so 2CH3OH. Methyl alcohol, also called methanol. First product. Now again your situation is changing. Now CH4 plus O2, and now catalyst is molybdenum oxide, MO2O3, molybdenum oxide, and you are heating. Molybdenum oxide, second product I am talking about. If a molybdenum oxide as a catalyst you are using and heating, then CH4 plus O2, it will give formaldehyde. It will give formaldehyde, also called methanol, Al, aldehyde. Methanol, one carbon is there. Formaldehyde, acetaldehyde, formaldehyde. HCHO. HCHO is aldehyde group. H is there, then formaldehyde plus H2O. This is the second product. First product was methanol. Second product is aldehyde, formaldehyde. CH4 plus O2, HCHO plus H2O. Third product is, if suppose you have taken ethane, now you have taken in two cases methane, now suppose you have taken ethane plus 3O2, 2CH3CH2, two molecules of ethane plus 3 molecules of oxygen. Now here you are using manganese as a catalyst, Mn, manganese. And this manganese acetate actually you are using here, not a catalyst. Manganese acetate, CH3COO whole 2 Mn. Mn is a 2 plus, Mn plus plus. Then CH3COS there, CH3COOH, acetic acid. 1H you remove, then it will form acetate ion. Then 2 acetate ion, CH3COO minus, CH3COO minus. Then Mn has 2 positive, Mn plus plus, both will attach to the Mn, and it will form manganese acetate. In the presence of manganese acetate, ethyl alcohol gives ethanoic acid, means acetic acid. It will give acetic acid plus water. Keep in mind, because ethane will give ethanoic acid. Very simple things. 2 carbon is there, ethane 2 carbon is there. Then ethanoic also 2 carbon is there. But it will form acid, COOH group. Carboxylic acid group is COOH group. Then it gives 2 molecules of CH3. CH3 means ethane plus 3O2. It gives a acetic acid, 2 acetic acid, 2 CH3COOH plus 2 H2O. This is the third product. And fourth product, that is the methyl propane you have taken. Methyl propane means 3 CH3 is attached with the carbon. 1 carbon, 3 methyl group is attached. And fourth one is H. CH4 is there, then 3H is removed. 3H is substituted by 3 methyl group. CCH3, CCH3, CCH3. And fourth one is with H. Then this is actually 2-methyl propane. This is called 2-methyl propane, or methyl propane also you can tell. Okay. Then this 2-methyl propane plus KMnO4, its condition is different. KMnO4, potassium permanganate. Then oxidation will take place. Then now it was a CH. CH became COH. CH became COH because oxidation is there. 1 O introduced. Then now it became CH3 whole 3 COH. Or you can tell that to 2-methyl propane, 2 all, it form OH group. OH means alcohol. Then here you have seen first and last you got alcohol. Second was aldehyde, and third was ethanoic acid. Means 4 products you got. Methanol first product, second product aldehyde, third product acid, and fourth product alcohol. Means 2 times alcohol you got. Okay, first and last. This I have told you about the this things controlled oxidation. Okay, more reactions are there. Then now I am stopping only here because it will take more time. Next class I will continue because more these properties are there, and this conformation is also there. It will take time. That's why I will continue next class. Okay, thank you.